Hello friends and welcome at my channel. 3 more problems with Monsieur L'Hôpital. I cannot stop doing this, so at some point the number of exercises is gonna be too big for maybe this playlist, and maybe I will be making an own playlist for L'Hôpital, but not now. So let's go. We have a limit x towards 0, x to the power of sine of x. Isn't that nice? Well, let's see. X is running towards 0, sine of x is running towards 0. So once again, if you remember, as we were saying yesterday, kind of 0 to the power of 0, but you never know what can happen. So let's rewrite it. Limit x towards 0 as e to the power of ln x to the power of sine of x. So applying the logarithmical rules, we are going to have x towards 0 e to the power of sine of x times ln x. And now it's all about this guy. So let's see. We got the limit x towards 0 of sine of x times ln of x. All right. So as x is approaching 0, sine of x is approaching 0 as well. ln of x, we're approaching 0 from the right-hand side, is approaching minus infinity. Can I somehow rewrite it to be able to apply the rule of L'Hôpital? Yeah, there are many ways. I think the easier one is just to, well, I'm just inventing it right now. So I would say I will keep the sign up, and I'm gonna make it 1 divided over ln of x. I'm not sure this is the right choice. Maybe I should try another one, but we will see. So now this is the perfect case for L'Hôpital because the numerator is approaching 0. The denominator is approaching 0 as well because we're dividing 1 by an infinitely large negative number. So let's ask Mr. L'Hôpital for help. We're gonna get a limit x towards 0 cosine of x in the numerator. Now we have ln to the power of minus 1 of x. Producing derivative of it would be minus ln to the power of minus 2 of x times 1 divided by x. Is it helping us? Well, let's see. So basically we can take minus in front, and we are having 1 divided over x times ln squared of x. That would mean I'm getting to minus a limit x towards 0. We can bring it now up. So it's x times ln squared of x times the cosine of x. So what's happening here? X is 0, ln squared is getting worse, cosine is 1. Well, I'm not getting anywhere. So maybe it wasn't a good choice. Well, that's life lesson, so let's do it again. Limit x towards 0. Now I'm keeping ln up, and I'm going to 1 divided by sine here. So that's life, you know. Let's see what's happening here. So this is a limit x towards 0. And now we're going to get 1 divided by x. And here we have sine now to the power of minus 1 of x. Producing derivative of this is minus sine to the power of minus 2 of x times cosine of x. So let's see. I can take again minus in front. We have yeah, that would be a cosine here and sine squared of x, if I'm right. Think I am. And we can rewrite it as a minus limit x towards 0. Let me switch the colors. So I would have sine squared of x divided over x times the cosine of x. And now I'm done. Why is that the case? Well, look, I can write it as sine of x divided by x. We've done this limit previously. And now one more sine of x divided by the cosine of x. Cosine of x, if x is approaching 0, is 1. This is 1 as well. And sine is 0. So overall, we're going to get a 0 value. So this result, this was my unsuccessful trial. This one is becoming 0. So really we have e to the power of 0, which is 1. This is the first limit this time. What about the second one? Well, let's do it. Limit x towards 1. We gonna get 1 minus x to the power of the cosine of pi divided by 2 times x. Okay, so what's happening here? We have 1 minus x, which is 0, if x is running towards 0. And we have cosine of pi divided by 2, which is 0 again. So we expect 0 to the power of 0, which should be 1, probably. Should we use e notation? I think there is no other way, right? So we gonna rewrite it as a limit. X towards 1, e to the power of ln, 1 minus x to the power of cosine pi halves times x. I'm bringing it down again. So this is e. Now we bring cosine pi divided by 2 times x times ln of 1 minus x. Now what we have is the cosine of pi divided by 2 times x, which is basically 0, and 0 times 0. We just have to rewrite it again. I was keeping ln in the previous example in the numerator at the second guess, and it was fine, so let's keep it this way. So it's all about now the limit of x towards 1 of ln 1 divided by x divided over 1 over cosine of pi halves times x. So L'Hopital's rule is giving us 1 divided by 1 minus x in the numerator. The cosine is giving us minus sine. I can kick minus out. It's minus sine of pi divided by 2x times, well, the inner derivative, which is pi divided by 2. Okay, let us rewrite it. I think I was kicking minus out and then rewriting it again. That's very nice. So pi divided by 2 means 2 divided by pi in front of the limit. Then we have a limit x towards 1. How can we rewrite it? Well, I was doing a mistake, right? And nobody's correcting me. Okay, of course, this is a YouTube video and nobody can correct me. I'm sorry, guys. Here's a mistake. I have a denominator, which I'm rewriting differently. So this is cosine to the power of minus 1. So minus 1 is fine. Now I'm gonna get a cosine of pi divided by 2x to the power of minus 2, which is fine now. And now we're multiplying it times the minus sign. So this is becoming plus of pi divided by 2x, and then 2 divided by pi is coming up. Holy moly. All right, so it looks like a mess, but let's clarify it. This is a good thing about mathematics, right? Doesn't matter how hard it looks like. At the end, there is, well, at least at the university level or at the high school level, there is always a solution. All right, so let me try to put it correctly. First of all, 2 divided by pi is fine. Plus we got is fine as well. Okay. Then we have a limit x towards 1. 1 divided, let me write it again, not to get confused. We keep this one the way it previously used to be. So now we have sine of pi divided by 2 times x. Divided by the cosine squared of pi divided by 2 times x. So basically we are having this one, limit x towards 1. Cosine is coming up. Divided over sine of pi divided by 2x times 1 minus x. So let's see what's happening here. If I put for x 1 right now, I'm going to get a cosine squared of pi divided by 2, which is 0. If I'm going to put 1 for x in the denominator, I'm going to get here 1, but here 0 again. So it's a case for the second step by L'Hopital. I think I'm not going to do 3 examples tonight, but rather 2. But that's all right. So we got 2 divided by pi. I really have to go to L'Hospital if I'll make it completely fine here tonight. So we have a limit x towards 1 still. Well, this is 2 cosine of pi divided by 2x times minus sine of pi divided by 2x times pi divided by 2. Pam, pam. Denominator. What do we have there? Product rule, right? Product rule, we have cosine of pi divided by 2x times pi divided by 2 times 1 minus x. And the inner this derivative gives us minus 1, and we keep sine. So just minus sine of pi divided by 2 times x. Let's just minus, not times. Okay. Whew, what's happening now? If I put for x1, this one is 0. This one is 0 as well, completely. Both cosine and 1 minus x. But this one is 1, and this is minus 1. So the result, if I'm not wrong, is minus 2. So that means we're back here at our example, and we would like to figure out this result, which became minus 2. So this is e to the power of minus 2, or 1 divided by e squared. Thanks for watching. See you in the next video. Sorry for the mess, but that's life. Bye-bye.